All right, this is what we're going to do. Data collection techniques. How do you get information from a population, right? Uh, and then how to actually design that so that you get a representative sample from your population. We'll discuss how to design an experiment, right? The difference between an experiment and observational study is that you're going to affect some sort of a treatment, right? You're gonna kind of twist things up and see if it makes a difference. And then we'll discuss different sampling techniques as well. Fantastic. Here we go. Hey, if we're going to design a statistical study, we're going to have to identify the variables of interest and the population of the study. Right, just like it said. Okay, we're going to develop a detailed plan for collecting data. Use a sample. Make sure the sample is representative. That's easy for me to say. Representative of the population. Which we've said. I mean, we've been talking about that for a while, right? Then collect the data. We'll describe the data using some descriptive statistics techniques, right? So we'll say, hey, this percent for this, that percent for that. And then we'll make some sort of an interpretation using inference, which is going to come later on in the course. We'll learn about inference and see if there might be any errors after inference and think, why didn't we get the result that we wanted, or why did we? Okay, so one method of data collection would be to have an observational study. So you're not going to do anything to the population to try to get them to do something different or to influence an answer or whatever response you're trying to get. You're just going to observe. And
observational studies are going behind a class or a two-way mirror, influencing their subjects whatsoever. They don't even know they can observe.
Okay, so another method of data collection, an experiment, right? Which was what I was telling you. We're going to apply some treatment, right? So we're going to actually see if we can do something to change the response. There's a good example. Okay. We can also get some data using a simulation. We actually did a simulation using cards, right? We didn't have to use a computer. We were able to use cards. In order to simulate randomly choosing whether water was tap water or bottled water, right? We did that. We'll often do this, right, in order to determine if something happened just by chance or if whatever we were trying to observe actually did influence the outcome. I'm sorry, this over here says is. A survey is conducted on a sample of female physicians. Actually, let's see if I can get this. I'm sure you guys are familiar with surveys and have responded to many. Sometimes you get a choice, sometimes you don't. A good survey would be one in which you actually don't have a choice. Everybody answers the survey.
Don't all surveys have choices?
Well, you have a choice as to whether you take it or not.
Oh,
Right, so there are surveys that we administer here, right? At the end of the year, you guys all get online, take a survey, answer questions about the school, about your teachers, and stuff like that. And we really want to get everyone to answer, right? It's like, hey, everybody has to do this. That's a good survey. A lot of times, if you get the choice as to whether or not to answer a question on a survey, well, people that feel strongly about whatever it is they're being surveyed about are gonna do the survey. Well, people that are like, I don't really care about this, they might not do it.
it could motivate into a kind of survey.
Yeah. All right, here we go. Let's get an example in. What method of data collection would you use to collect data for this particular study? So a study of the effect of changing flight patterns on the number of airplane accidents. So would you use an experiment, an observational study, a simulation, what, or a survey? What do you think?
I think it's observation. You're not going to crash planes on purpose.
You definitely wouldn't do an experiment, right? Yeah, a simulation will work. I mean, you could do an observational study, but there's probably not a lot of data points out there, right? I mean, it's an awesome thing that planes don't crash very often, right? So it would be hard to see to sort through all the data, figure out which plane crashes resulted. Which plane crashes were the result of changing flight patterns. You're probably not going to have a lot of examples like that. It's going to be hard to get some data. So in that case, a simulation would be better. Because you could get a computer to do the thing, hundreds of thousands of times and see what the result is. All right. All right. So which one would you want to use for this? A study of the effect of eating oatmeal on lowering blood pressure. So you say survey, what do you think? Experiment? What do you think? Same experiment? Yeah, so for a survey, you'd want to, if you wanted to know maybe how many people eat oatmeal for breakfast, or how many times a week does the average person eat oatmeal for breakfast, something like that, right? Then you would want to do that. But for this one, you would want to do an experiment, because then what you could do is you could have a group of people, right, that you would select, and you would have them just eat their normal breakfast, or not eat breakfast, it depends on how you would want to do it. And then you would have an experiment group, right, so that would be your control group, the ones that don't eat oatmeal. Then you would have an experiment group. They eat oatmeal for breakfast, and you then are able to, at the end of it, measure their blood pressure and see if there's a significant difference. All right, let's look at this one. How about if you wanted to figure out how fourth grade students solve puzzles? You'd want to go with an observational study.
Dudes? What's up?
I wish that they were more specific about this. How fast they can solve a puzzle. Maybe,
Right.
Alright, study U.S. residents' approval rating of the U.S. president. How about you, man? A survey would probably be the way to go, right? Ask people, do you like the president? It's pretty easy, yes or no. Alright, fantastic. You guys are getting this. Moving along. I'm going to have to look at what the try it yourself one is, for some reason this slide got erased. So think about which method of data collection you would use for each. Yeah, I'm not sure. So for one, it's pretty clear, right? What would you choose for one? You would experiment, right? Yeah, you could, because you're not gonna. They'll probably benefit from some exercise. Who doesn't, right? Yeah, for the exercise, for number one. You can, I mean, you know, as long as you're giving them exercise that's within the limits of their health, you're probably not going to cause pain. However, with number two, you could not use an experiment, right? Because that would be messed up. That would be really wrong. Huh? Yeah. Huh? Yeah. You could do. I'm not sure how you would do a simulation, but it seems like the best way to go.
You do a simulation anytime, one, there's a risk of bodily harm, or two, that it's so astronomically expensive, you cannot do an experiment or an option. So those are the two key things for a simulation. One is usually computer generated, and two, it takes out the cost and the health risk. So you can't go, they do it all the time. They do responses to plane crashes. They do, the smoke jumpers do the fire. They train all year for the fire season. They can't actually start a fire in December, a forest fire, but they train for it because of the risk. They would do a simulation, not an actual experiment.
All right, so for experimental design, actually putting together an experiment, you have to input some sort of control group, right? So you're going to have a control group, you're going to have an experimental group, right? There has to be some sort of randomization. So you have to randomly select people to be in each group, in your experiment group and your control group. And then replication means that you got to have enough people in each group that differences in people aren't really what you're measuring. What you're measuring is your treatment, your whatever you've done to your experiment group, right? You don't want to accidentally measure, if you had a bunch of females in one group and a bunch of males in one group. You don't want to wind up, or like if you had a bunch of females in your experimental group, you had a bunch of males in your control group, right? And you wanted to study the emotional effects of watching The Notebook. You're going to get some weird results that way, right? If you don't have a good mixture of males and females in both your experimental and your control group, okay?
And the last one on replication too, you gotta be able to repeat it. You're trying to cure cancer, and you can't repeat it.
So just like what I was saying, right? We want to control for effects other than the one being measured, right? So again, like I said, if you're you wanted to figure out the emotional effects of watching The Notebook, something like that, you would want to make sure that you had an even distribution of males and females, so that you didn't get skewed. So what would be our confounding variable in that case would be gender, right? So the confounding variables, they're going to occur when an experimenter cannot tell the difference between the effects of different factors on a variable. And there's a good example. All right, so have you guys ever heard of the placebo effect?
Yeah.
Right, so you gotta take into account that the placebo effect does not have that effect. So, the best example is when they're trying to test the effectiveness of a new drug. They will have an experiment group that they'll give the new drug to, and then they'll have a control group that they'll give a placebo, usually like a sugar pill, right? Pills look exactly the same. Everybody takes a pill, so the only difference is one actually has medicine in it and the other one doesn't. But what's funny is they found that sometimes people will actually be positively affected by the placebo just because, because they're faking. I think that, yeah, because they're exactly because in their mind they're like, hey, I'm taking this medicine, it should be making me feel better, and then sometimes it actually does, and it's not the medicine that's making you feel better, it's just their mind. It's kind of an interesting thing. So also talking about blinding. So proper blinding techniques. Use your thought. No, just kidding. So, right, the subject doesn't know whether they're getting a placebo or not, which is good, right? Because if you told them they're getting a placebo, then that could affect the outcome. And double blinding is best when you're doing something like that because, right, if the person giving it is usually a doctor, if it, in the case of testing in medicine or something like that, right, a doctor might want the outcome to be favorable, and so they might, without even knowing it, right, they might kind of favor the ones that are getting the medicine. So if they're getting better treatment, then you're not looking at the effectiveness of the medicine. You're then measuring like the effectiveness of this doctor giving them better treatment. So it's always best if they're doing that to have a double blind. All right. So randomization. So for randomization, we talked about why you would want to randomly assign people, right? We don't want there to be some sort of a bias and influence, right? We all have these biases, whether you know it or not, right? You might, if I was to just say, hey, you, and you, you're in the experiment group, and you, and you, you're in the control group, without randomly assigning them, I probably am influencing who I pick. There's probably just human beings just are that way. We like certain things, some things, we just choose things based on what we like a lot, right? We wouldn't want that to be an influence in the way that we chose people for an experiment.